So I might as well. And then I'll share my writing pad so I can write on it. Share screen. Where is my writing pad? Here. Share. Okay. I have some crap here, so let's go to, let's create something new here. Some space. So, can you see my notebook? It's just a blank grid paper.
Yeah.
Okay, we have test 5, question 3. Is that right?
Yeah.
So, it is consider a gear with a pitch radius, etc., etc. The gear is designed 10 kilowatts. If the AGMA, okay. So if the AGMA number is wrong, what happens to the power rating? That's the question.
So it draws a different amount of power.
And what, so where did you, what is the thing that you are finding it difficult? Because there are 2 equations there.
I'm not sure what the equations mean. Like the x bar ft times. Where are they in like the lecture?
Now this sigma t, you know, in the lecture we have a sigma t equation. I'm going back to the lectures.
The bending stress and the constant.
Yes, that's right. And I, which was, I'm just going to write it from memory. I may be wrong. I think I am correct. Fd divided by b, phase width, times module, times the bending, which was I, wasn't it? Ratio, and then a bunch of factors. KT, KO, KM, KB, etc., and KV. Now,
so is it supposed to J, not I?
Oh, sorry, J. Sorry, that's yeah. Thank you. Yeah, AGMA is for pitting. Thank you, J. So here, AGMA quality number only affects this one. See, no? That's really depends on AGMA number. All the rest, they are not affected by the AGMA number. So what we can all put them here, say that, okay, this is a whole bunch of things. I say this is a whole bunch of things. Okay? That's what export. You understand?
Yeah.
So this is equal to safe operation means sigma t is equal to SAT. That's also constant. SAT doesn't change either because SAT doesn't depend on AGMA number either. So then you have FT times KV times a whole bunch of things is equal to SAT. So you have 2 KVs, one for the old original AGMA number, one for the new AGMA number. So you can calculate the change and see what is going to be the FT now if the KV is changed. Because you can say that FT original one okay, this is one, and the second one, this is for the safe operation. We're trying to calculate the safe FT, KV2. You can find from here what is going to be the FT2? Because KV2 will change. You understand?
Mhm.
Do you understand these two equations?
Yes. Yes.
And if you divide them by each other, you don't really have to know SATs, because when you divide them, what you get is FT 1 over F2 2 times KV 1 over KV2 is equal to 1. Okay? You understand that? This one?
Yes.
Well, then surely then you can find the FT2 over the new power is going to be FT2 over FT1. You can calculate that ratio.
Right.
You do the same. I mean, you have a similar relation from the pitting, and so whatever that ratio directly determines the power. I think you have to think a bit more. I'm not going to give you any more of the intermediate steps, but that should give you some guidance into what you do.
For the KV dynamic factor, we just read it off depending on, because we have A7, so
KV depends on the speed only and AGMA number.
speed.
So let's calculate KV. So we have omega is given.
There.
Omega is given as 30 radians per second. Okay. And pitch radius is given as 0.1 meters. So from here, linear velocity is 3 meters per second. Happy with that? Then let's calculate the KV. I'll just call you can look it up from the chart. I'll just call the library function with I'm just trying to look at the syntax of that library function. Yes. AGMA number, which is, was it the first one was A7, wasn't it? Yes. In quotation, and then 3. And that will give you, I'm just going to do the calculation now in the way I did with Azul. I'm not going to, in fact, I can go there again, just new share. So you see this, so let's add to the end, new VT. VT is equal to 2, so 3. So print AGMA KV, A7, VT. I also add AGMA KV here, so it will know where to get it from.
Hal?
Yep.
Azul wants to go to breakout room.
Okay. Just a sec, Chantal. Stop share. Breakout room. I'll assign you in SK to breakout room 2. Okay.
Right.
Yeah.
Thanks.
So there is only Sheena. Okay, go back to share screen, which is this one. So I add that. Just let's run this. Are you with me, Sheena?
Yeah. I'm
Okay, so for that VT, I just get to delete all this because that's going to confuse all of us. And run this again, Control Enter. 1.106, that's the KV for A7.
KV.
KV. So maybe, so I'll just calculate that on a separate line. KV1. Okay?
Mm-hmm.
And let's calculate the second KV. It's A10, isn't it? That's what happens.
Yeah.
And print that one too. Control Enter. Because VT, what happened here? KV, that should be KV2, of course. Yep, okay. Okay. So that calculates KV1, KV2. So you go back to my writing pad. So you can calculate the F ratios. That's the ratio. The ratio between the tangential force is the ratio between the powers. Surely, Shina, after this, you can solve this equation. You need to think a bit more, but I think it's better that you do that thinking rather than I really take you to the next step.
I think I was stuck on calculating KV because I was a bit confused on the graph. But
KV is a function of the linear speed. You can either look it up from the table. If I go to new share, go back to this one. So this one. L10. This is KV. So you calculate the pitch line velocity, which was, what did we calculate for the first one? It was 3. So I'll make this a bit larger. So 5, 2.5. So let me get some. So we're going up from here. So the first one was A7, which is this. And the second one is A10, which is here. So you can calculate them from these two.
okay.
Just look it up from the chart. There is enough error margin to account for the differences between the precise calculations by using the library or by eyeballing it from the chart as I did now. Does that tell you how to calculate KV?
Yes.
Because as you can see, it is as the velocity gets higher, the effect of the diagonal number becomes very important because it is really something that represents the vibration.
Wait, could I see the notepad that you had before again?
Sorry?
Can I see the notepad you were writing on before?
Oh, yeah,
again?
sure. Okay? So that's how you do question number 3. I'll stop share. Oh, I won't stop share, but you can take a look at it, but I'll just stop Actually, I cannot stop recording until I stop share. So tell me when to stop sharing.
You could stop share and then stop recording and then put it
And then
back up
back
if
it
you want.
again. Okay, that's good. Yep, thank you.
Thank you.
Stop recording.